Right, guys, multiplying and dividing fractions. A rather procedural topic, so it's something that you can really learn on your own. Before we start multiplying and dividing fractions, you have to have some baseline knowledge. The first thing you have to know is how to turn mixed numbers into improper fractions. This is a mixed number because it's a mix between a number and a fraction. We're going to turn into an improper fraction. An improper fraction is a fraction where the denominator is smaller than the numerator, okay? So how do we turn 2.5 into an improper fraction? All you're going to do is this. Your denominator stays the same. To get your numerator, you're going to multiply your denominator by the whole number. 2 times 2 is 4, plus 1 is 5. Same thing here. 7 times 3 is 21, plus 2 is 23. 10 times 9 is 90. 10 times 9 is 90, plus 7 is 97. Denominator stays the same. You can do these ones. Then we're going to do the reverse process, turning improper fractions like this back into mixed numbers. All you're going to do is this. How many 2's go into 13? 6 2's. 6 2's is 12, which is a remainder of 1 from 13. And the denominator stays the same. How many 10's go into 61? 6. 6 times 10 is 60, which is a remainder of 1. Your denominator stays the same. I'm going to change this one to 15 over 4. How many 4's go into 15? 3. 4 times 3 is 12, which is a remainder of 3 from 15. Your denominator stays the same. So you can do those ones by yourself. Now, how do you turn any whole number into a fraction? This is quite an important skill. If I wanted to turn 6 to a fraction, all I would do is I would do 6 over 1. 7 as a fraction, 7 over 1. 88 as a fraction, 88 over 1. So spot the pattern. Okay, let's get into multiplying fractions. Multiplying fractions is very easy. Numerator times numerator, denominator times denominator. 1 times 2 is 2, 7 times 3 is 21, 4 times 3 is 12, 9 times 5 is 45. Actually, let's go back, get your answer, let's try and simplify it. What can we divide both numbers by? Nothing, that's our final answer. What can we divide both these numbers by? 3. So, divide 3, which is going to be 4 over 15, and that's our final answer. 2 times 6 is 12. 15 times 7 is 105. We can divide both these numbers by 3. $105 divided by 3 is 37, I believe. No. 33, 35. Okay, and that's how you do it. Now, it's just top times top, bottom times bottom. Now, there's a little trick you can do if you want when you're multiplying. I'll write it down. When multiplying fractions, before you start multiplying, you can simplify diagonally. Because if I do 100 times 88, that's pretty hard. That's going to be a pretty big number. And 99 times 200 is also a pretty big number. What we can do, it only works when you're multiplying fractions, is you can simplify diagonally. So 100 and 200, I can divide both these numbers by 100. So 100 divided by 100 is 1. 200 divided by 100 is 2. Let's look at this diagonal, 88 and 99. What can we divide both these numbers by? 11. So 88 divided by 11 is 8. 99 divided by 11 is 9. Now it's going to be a much easier question. 1 times 8 is 8. 9 times 2 is 18. Let's simplify our answer. We can divide both numbers by 2. Equals 4 over 9. Here. That's 8 times 24, that's going to be a bit of a pain. 12 times 7, that's a bit of a pain. Before we multiply, let's try and simplify diagonally. 12 and 24. I can divide both these numbers by 2. 6 and 12. I can keep going. I can divide both these numbers by 2 again. 3 and 6. I can divide both these numbers by 3. 1 and 2. And 7 and 8, can I simplify those ones? No, nothing. So now it's going to be 1 times 7 is 7. 8 times 2 is 16. Can I simplify that? No. So when you're multiplying, Before you multiply the fractions, see if you can simplify diagonally. You can do these questions. Now, dividing fractions. Now, when we divide fractions, we don't do 1 divided by 2 and 7 divided by 3. We use a phrase called KSF. I'll put it over here. KSF. KSF means keep, switch, and flip. So what you're going to do is we're going to keep the first fraction the same. We're going to switch the division into a multiplication, and we're going to flip the second fraction. And then it's a regular multiplication problem. 1 times 3 is 3. 7 times 2 is 14. Can we simplify that? Nope, that's our answer. Keep, switch, flip. 4 times 5 is 20. 9 times 3 is 27. Can we simplify that? No. Keep, switch, flip. Cool. Can I simplify that? Yeah, I can divide both numbers by 2. 14 divided by 2 is 7. 30 divided by 2 is 15. This one. Keep, switch, flip. Ooh, these are nasty numbers. Maybe we can simplify. Maybe we can simplify diagonally. So remember, guys, you can't simplify diagonally here because the fractions are being divided. You can only simplify diagonally once the fractions are being multiplied. So let's have a look diagonally. Oh, we can divide both these numbers by 100. So 1 and 2. And both these numbers by 11. 8 and 9. 1 times 8 is 8. 9 times 2 is 18. Let's see if we can simplify this. 18, divide them both by 2. So 4 and 9. Last one, keep, switch, flip. I don't want to do 8 times 24. The fractions are being multiplied. Let's simplify diagonally. We can divide both these numbers by 12. 24 divided by 12 is 2. 1 times 7 is 7. 8 times 2 is 16. And we're done. You can try these questions by yourself. Now, we're gonna go back to multiplying fractions, but we're gonna add some spice. We're making it a bit spicier. We're gonna add some mixed numbers in. We're gonna add some whole numbers. Okay, so what you want to do here is if you're multiplying a whole number by a fraction, you want to turn the whole number to a fraction, which is going to be 3 over 1. Top times top, bottom times bottom. 1 times 4 is 4. This is an improper fraction. This is a good answer, but let's make it mixed. How many 4s go into 9? 2. 4 times 2 is 8, which is a remainder of 1, and our denominator stays the same. Base of fraction. Over 5. This is correct, but let's make it mixed. How many 5s go in 14? 2, the remainder of 4. Here, if you have a mixed number, you have to first make it improper. So 3 times 2 is 6, plus 1 is 7. Our denominator stays the same, times 4/5. That fraction's fine. 7 times 4 is 28. 3 times 5 is 15. How many 15? And this is our answer, but it's improper. Let's turn it into mixed. How many 15s in 28? 1. 15 times 1 is 15. To get to 28 is 13 extra. That's your answer. Here, there's 2 mixed numbers. I got to turn both into improper fractions. 3 times 2 is 6, plus 1 is 7. 3 times 7 is 21, plus 2 is 23. Cool. I don't want to do 7 times 23. Can I simplify diagonally? Yes, because the fractions are being multiplied. Let's look at 7 and 7. I can divide both these numbers by 7. 7 divided by 7 is 1, and 1. So 1 times 23 is 23. 3 times 1 is 3. How many 3s in 23? 7. 7 times 3 is 21, with a remainder of 2 over 3. Last one. I've got to turn this fraction into improper. So 3 times 4 is 12, plus 1 is 13. 13 over 7 times 7 over 1. I'll simplify diagonally. Divide both sides by 7. 13 times 1 is 13. 1 times 1 is 1. any number over 1 is just going to be itself, which is going to be 13. You can do these ones. Next. Oops. We should all be divide. My bad. Sorry. Okay. Okay, first things first. Let's turn 3 into a fraction. So 3 over 1, divide by 3/4. And only once both fractions are in a desirable format, we're going to keep, switch, and flip. So keep the first fraction the same, switch the division to multiplication, and then flip. Three times 4 is 12. 1 times 3 is 3. How many 3's go into 12? Well, exactly 4. That's our answer. Here, let's put both these fractions in a good format. So 2/5 is perfect. 7 is 7 over 1. Now, once they're in good format, we're going to keep, switch, and flip. So keep, switch, flip. 2 times 1 is 2. 3 times 5 is... 5 times 7 is 35. That's your answer. Here, make this improper. 3 times 2 is 6, plus 1 is 7, so 7 over 3. Divide by 4/5. That one's fine. Then I'll do my keep, switch, and flip. So you're only going to keep, switch, and flip once both your fractions are perfect. Times 5 over 4. 7 times 5 is 28. 3 times 4 is 12. Let's turn this into a mixed number. How many 12s in 28? 2. 12 times 2 is 24. With a remainder of 4 over 12. I can simplify 4/12. I can divide both the numbers by 4. So our whole number stays the same. 4 divided by 4 is 1. 12 divided by 4 is 3. This one? 2 improper fractions. So 3 times 2 is 6, plus 1 is 7, so 7 over 3. Divided by 7 times 3 is 21, plus 2 is 23. Cool. And then both fractions are perfect. I'm going to do my keep, switch, and flip. So 7/3 times 7 over 23. Can I simplify this diagonal? So now once the fractions are multiplied, can I simplify this diagonal? No, nothing in common. Nothing in common here. So just 7 times 7 is 49. 3 times 23 is 69. Last one. 4 1/3 divided by 7. So 4 1/3, make it improper. So 4 times 3 is 12, plus 1 is 13. Divide by 7. We have to make that a fraction, 7 over 1. Now it's in a good format. We're going to keep, switch, and flip. So keep, switch, flip. 13 over 21. And that's your answer, okay, guys? So only keep, switch, and flip once you have two fractions, okay? So 2/5 divided by 7, I made it 2/5 divided by 7 over 1. 2 perfect fractions. Then you do your keep, switch, and flip. Here, you have to make this fraction improper. This one stays the same, so it's 7/3 divided by 4/5. Then you can do your keep, switch, and flip. Here, you have to make both fractions improper. And only once you do that, then you can do your keep, switch, and flip. All right, so you can practice these questions by yourself.